In this video, we'll be taking a look at simultaneous equations and how to solve them, specifically looking at linear, and then doing some practice questions to actually test our knowledge. So, starting off with the basics, there are two types of simultaneous equations. One is linear and the other is quadratic. Now, in this video, part 1, we're going to be looking at linear specifically, and in the next video, we'll take a look at quadratic. So, what is the difference between the two? So, just taking a look here, we can see that linear is in the name. Both of these equations are linear. With quadratic simultaneous equations, usually one of the two equations is quadratic, so it has either something to the power of 2 or to the power of 3. Sometimes both of these equations can be quadratic, but usually it's only one. So with linear, usually both of them will just be linear. Quadratic, one will be quadratic and the other will be linear. And based off of this, there are different methods that we use to approach both of these types of equations. Okay, so let's look at how we can actually solve for linear simultaneous equations. Now, with simultaneous equations, the goal is to pretty much just find a value for x and y, or any two other unknown letters. So with linear equations, we're going to have one value for x, one value for y. Okay, so here we've got two equations. We can see they're both linear. There's nothing to the power of 2 or anything like that. So now the first step is we need to rearrange both of these equations so that the x's and the y's are lined up. Now, in this question, they've already given us both equations in that format, which is fine. If, for example, this second one was written as 2y plus 7x equals 13, we would need to rearrange either this one or the top one to make sure the x's and the y's are lined up, okay? Because we are going to need that for the following step. So I'm just going to go ahead and write down both of these equations. Now the next step is we need the coefficients to y or x, just one set of them, to be equal. Now again, in this question, we've already got one set of coefficients that are equal. So we've got minus 2y plus 2y. Doesn't matter about the signs, more just about these numbers here. Now, if that wasn't the case, if this, for example, was 3y and 2y and nothing matched, we would need to multiply either one or both of these equations to make one set equal, kind of like in fractions when you're trying to get a common denominator. You multiply both of the fractions to get a common bottom number. It's kind of the same thing here. So we need to pretty much either add or subtract these two numbers to cancel them out. That is why we need them to be equal in the first place. So starting off, looking at this matching set, we've got minus 2 and plus 2. So we need to see, do we need to add or subtract these two numbers to get to 0? So minus 2 plus 2 will give us 0. If we minused, it would give us minus 4. So we are going to add. Okay, and whatever we do to this set of numbers, we're going to do to the rest of the equations. Okay, so this is going to be add, and here too. So now we're going to apply this to all terms. So 3x plus 7x is 10x. This is 0, so it cancels out. 7 plus 13 gives us 20. So you can see now, using this method, we are now able to work out a value for x. Okay, so 10x is 20, x equals 2. Okay, the next step is to find y, the corresponding letter. Okay, so what we can do is we need to sub this value back into any equation just to find the value of y. So let's try it with the first equation. 3 brackets 2 minus 2y equals 7. 6 minus 2y equals 7. minus 1 equals 2y, minus a half equals y. And there we have solved for x and y. Now, the thing with simultaneous equations is the value that we get for x and y needs to work in the first equation and the second equation. Because if you think about it, we could make up a value for x and make up a value for y to give us 7. That might work in the first equation, but there's no guarantee that it will work in the second one. So the whole point of working out x and y this way is that we find values for x and y that work for both equations. That is what we want. So we can see from our working out here that the value of x equals 2 and y equals minus a half, it works in the first equation. Now what we need to do is check that both of these values for x and y work in the second equation as well. And if it does, we know our working out is correct. If not, something's wrong and we need to go back and check our working. Okay, so now let's sub in these values to the second equation. That's minus half. Minus 1. And that works. So now we are sure that x equals 2 and y equals minus a half. Now, simultaneous equations is one of those topics where if you're able to do these checks and confirm that your values for x and y work in both equations, you know you've got the right answer confirmed. And if you've shown all your working out, you are guaranteed to get full marks. Okay, so now let's move on to some practice questions. Okay, now we'll work through these together. So the first step, get the x's and the y's lined up. So this is already done for us in this question, which is fine. Next, we need to cancel out either the x's or the y's. So we need the coefficients to match. Now here, no coefficients are matching. So we need to multiply these equations for us to be able to do that. Now we can go with either one. I'll do x for now. So I'll times this equation by 2 and this equation by 3 to give us 6x on both of them. So times by 2 times by 3. Now that is going to give us 6x minus 2y equals minus 8. So we're multiplying the whole equation, all of the terms. Bottom one, 6x minus 9y equals 27. Okay, so now we've got this set of coefficients matching. Now to cancel these two, we just need to simply minus. So we're going to minus here, minus here, minus here. So we always start off with the matching set of coefficients and we apply that to the rest of the terms in the equation. Okay, this is going to be 0. Minus 2 minus minus 9 gives us 7y. Minus 8 minus 27 gives us minus 35. Y therefore equals minus 5. So now we've got a value for y. Let's find the corresponding value for x. Now you can use any of these equations, but I prefer to use the original equations just because that is what we're working with and that is where we want our values to match. So it just reduces any room for error. Okay, so 3x, which is what we're trying to find out, minus minus 5 equals minus 4. 3x plus 5, take it over, is minus 9. X equals minus 3. Okay, so now we've got our values for x and y. That's with the first equation. Now let's sub in these values in our second equation to make sure that they match. So 2 multiplied by minus 3 minus 3y, which is minus 5, should give us 9. Minus 6 minus minus gives us a plus. And there you go. Now we know that these values are correct. Moving on to the next question. Okay, so starting off with our first point, we need the x's and the y's matching. Now in this equation, we can see that that is not the case, and we're going to have to do some manual rearrangement. Okay, so what we can do is this second equation here we see equals 0. So we want to move on the top equation, we want to move this 4x over, so this equals 0 as well. So we might as well put this 4x to the front, and then both equations will be rearranged correctly. So this is going to give us minus 4x plus 3y plus 11 equals 0 now. And the bottom equation stays the same. 10x plus 2y plus 1 equals 0. So here we can see x's, y's both lined up, so we're ready to start. Next step, we need one set of coefficients to match. Now I think it might be easier to get the y's to match here because they're smaller numbers. So let's multiply this by 2, this by 3. Now that gives us minus 8x plus 6y plus 22 equals 0. For the bottom one, 30x plus 6y plus 3 equals 0. Okay, now we need to cancel out the y's. So positive and a positive, we're just going to minus. I'm going to apply that to all of the terms in this equation. So minus 8 minus 30 gives us minus 38x. This cancels 0. 22 minus 3 gives us 19 equals 0. Okay, so minus 38x equals minus 19. 38x equals 19. X equals a half. Okay, so now let's work out the y value. Let's sub in this value for x into this first equation here. So 3y, which is what we're trying to find, plus 11 equals 4 times a half, which is 2. 3y equals minus 9. Y equals minus 3. Okay, now we've got our values. Last step is to do our check. So we're going to do that with the second equation here. So 10 times by x plus 2y minus 3 plus 1. Now all of this should equal 0 if our values here are correct. So 5 minus 6 plus 1 equals 0. 5 minus 6 is minus 1 plus 1, 0. So we know these two are correct. Okay, so one more question we'll go over together, then I'll hand it over to you. First step, we want to get x's and y's lined up. Yep, that's done. We want to get matching coefficients. Yep, we can see here that the 3's line up. So now we can go ahead and solve for x. Okay, so we've got a plus and a minus here. So we want a plus, because a plus and a minus is a minus. That will cancel these two out. Therefore, we're going to plus here, plus here. Okay, 4x plus x, 5x. These two cancel out, equals 25. 5x is 25, x is 5. So now let's sub in this value to work out y using the first equation. You can do any, but we'll just start off with the first one to make it easier, and then use the second equation as a check. Remember, it's always good to show you're working out, even if certain calculations seem easy. It's always good to show a step-by-step process because it's good for your own working out, and these will get you additional marks. Okay, so we got our values for x and y. Now let's do our check with the second equation. X, 5 minus 3, which is minus 2 over 3, should equal 7. So 5 minus this times that will give us minus 2. Minus minus is plus. 7 equals 7. Okay, so we know these are correct. Okay, moving on, we've got some practice questions here. Okay, yeah, that's fine. So please pause the video here and have a go at these 4 questions, and we will work through them together once you're done. Okay, so let's go through the first one. Okay, I'm just going to create a bit of space here. We'll look at the rest after. Okay, so same thing as we did before. X's, Y's lined up. Let's match one set of coefficients. So we'll do the X's this time. I'm going to multiply this by 2, multiply this by 5. That gives us 10x minus 6y equals 48. For the bottom one, we've got 10x minus 20y equals 20. Now that means we are going to cancel out the x. So we're just going to go ahead and minus here. That means we minus there and minus there too. Okay, so this 0 minus 6 minus minus 20 is 14y. 48 minus 20 is 28. Therefore, y is 2. Okay, so let's find out the corresponding x value now. So we'll use this first equation. So 5x minus 3 bracket 2 equals 24. 5x minus 6 equals 24. 5x equals 30. X equals 6. Now for our check again, let's see if these two values for x and y work in the second equation too. So 2 bracket 6 minus 4 bracket 2, this should equal 4. So 12 minus 8 equals 4, 4 equals 4. Okay, so hopefully you got that one right. Moving on to the next question. Go through these one by one. Okay, so straight away we can see that the x's and the y's are not aligned. So let's go ahead and rearrange this top equation to solve that. Okay, so that's going to give us, if we move this 8x over, we're going to have minus 8x plus 2y, y stays the same, equals 11. Now the bottom equation, we've got 2x plus 8y equals 27. So yeah, that looks fine now. The x's and the y's are aligned, so we can go ahead to the next step. Now we want one set of coefficients to match. Both similar numbers, so we can do any. Let's just do the x. So we're going to times this by 2. We're going to times this by 8. So that will give us minus 16x plus 4y equals 22. Bottom, 16x plus 64y equals 8 times 27, which is 216. Okay, so now we need to cancel these x's out. So minus 16 plus 16 will give us 0. So let's go ahead and do that. Do the same to all of these terms. So plus, we're going to cancel that out. This is 68y, and this will be 238. Okay, so 238 divided by 68. 68 times 3 gives us 204. Missing 34, which is 0.5. So that's 3.5 as our value for y. Now we need to find the corresponding x value. So let's sub in this value for y in the first equation. So 2 times 3.5 equals 8x plus 11. 7 equals 8x plus 11. Take this over. Minus 4 equals 8x. Minus a half equals x. Okay, so now again our check. Let's see if this works in the second equation. 2 multiplied by minus a half plus 8 times 3.5. Now this should give us 27. Minus 1 plus 24 plus 4 is 28. All good. Okay, so now here we've got some worded questions, but in these types of questions we need to create the actual equation ourselves. Okay, so let's have a look. So sweets are sold in small packs and in big packs. There is a total of 175 sweets in 4 small packs and 3 big packs. There is also a total of 154 sweets in 5 small packs and 2 big packs. Work out the number of sweets in each small and big pack. Okay, so what you can see from reading this question is, first of all, small and big packs are the unknown variables in this question, so kind of like x and y. And they've given us 2 lines here, so these are our 2 equations. Now we need to create these actual equations and then solve for these unknown values. Okay, so here for the first one, 4 small, 4s, and 3 big packs equals 175. Second equation, there's 4s, not 45. 5 small, yeah, just write small here so we don't get confused. Second one, 5 small and 2 big. Just leave this as B just to make it easier. equals 154. Okay, so now we want to find the value for one small and one big. Okay, now because we've created these equations ourselves, we've got the b's and the s's lined up already. Now what we're going to do is try and get one set of coefficients to match. So we'll go ahead with the b's for now. Okay, so we're going to times this by 2, times this by 3. That gives us 8 small plus 6 big is 350. Bottom one, 15 small plus 6 big equals 462. Okay, so now let's go ahead and cancel these b's out. Plus and a plus, we minus. So we minus here, minus here. 8 minus 15 gives us minus 7 small. These cancel out. This gives us minus 112. So let's get rid of the minuses. Now 1 small equals 112 divided by 7, which is 16. Okay, now let's use this value to work out the value of b. So 4 times 16 plus 3b equals 175. 64 plus 3b equals 175. 3b equals 111. b equals 111 divided by 3. 37. Okay, now let's see again with our check, do these values work in the second equation? So just going to do it up here so we can still see all the working. 5 times 16 plus 2 times 37. Now this should equal 154. 80 plus 74. Okay, so these are both correct. Okay, moving on to the last practice question here. Again, it's a worded question, so we're going to need to create the actual equations. So at a cinema, 2 adult tickets and 3 child tickets cost £27. 3 adult tickets and 2 child tickets cost £31. Find the cost of each. Okay, so fairly straightforward. 2a plus 3c equals 27. 3a plus 2c equals 31. So we've got the unknown letters lined up. Let's match one of these coefficients. So times this by 2, times this by 3. So 4a plus 6c equals 54. 9a plus 6c equals 93. So we're going to cancel the c's out. So we're just going to go and minus that, minus that, minus that. 4 minus 9 minus 5a, this cancels out, equals minus, okay, so get rid of the minuses, so 5a equals 39, A equals 39 over 5, so 35 divided by 5 is 7. 4 over 5 is 0.8, so cost of an adult ticket is £7.80. It's not a round number, that's fine. So now we've got the cost of adult ticket. Let's find out the cost of a child ticket. So let's sub that into the first equation. Plus 3c equals 27. 15.6 plus 3c equals 27. 3c equals 27 minus 15.6, which is 11.4. C equals 11.4 divided by 3. Let's work that out. I'm just assuming that this is from a non-calculator paper. That's 3, that's 3, into 8.8. So the child ticket is £3.80. Okay, all good. Now final check. Let's sub in these values to the second equation and we should get 93 as our total. Okay, it's going to be a bit of a long-winded multiplication, but it's fine. So 7.8 times that by 3 gives us 23.4. Let's times that by 3. It gives us 70.2. And 6 times 3.8. 3.8 times 2 is 7.6. Times that by 3. 22.8. So 70.2 plus 22.8 gives us 93. Okay, so this value for A and C is correct. It's a bit long-winded with some of these decimals, but that's fine. The same process applies whether we have a worded equation or we have two equations already given to us. Okay, and to finish off this video, I've got 2 bonus questions here. Please attempt these 2 questions and that will be linear simultaneous equations done. And in the next video, we can move on to quadratic simultaneous equations. So please pause the video, attempt these 2, and we'll quickly go over them once you're done. Okay, so we can see here that we've got another worded question. So we need to create the actual equations for us to work with. Okay, I'll go through this one by one. A market stall sells apples and bananas. David bought 4 apples and 3 bananas for $4.10. John bought 2 apples and 5 bananas for $4.50. Find the price of 1 apple and 1 banana. Okay, so let's go ahead and create 2 equations, fairly straightforward. So 4a plus 3b gives us 410, and 2a plus 5b gives us 450. So a's and b's lined up. Now let's match one set of coefficients. If we were to multiply this bottom equation by 2, we would get 4 and 4. So let's just go ahead and do that. We don't always need to multiply both equations. Sometimes we can just multiply one to get one matching set of coefficients. Whatever is easier. Multiply by 2. So that gives us so the first equation remains unchanged. The second one, 4a plus 10b equals 9. So now let's cancel the a's out. We're going to minus. Three minus 10 gives us minus 7b. 410 minus 9 gives us minus 490. Let's get rid of the minuses. B equals 490 divided by 7, so that is 0.7. So 0.770p for one banana. Now let's go ahead and plug this into the first equation to give us the value of a. So 4a plus 3 bracket 0.7 gives us 410. 4a plus 2.10 equals 4.10. 4a equals 2, therefore a equals a half, or 0.5. Okay, now our final check. Let's just see that these values work in the second equation as well. So 2 multiplied by 0.5 plus 5 multiplied by 0.7 should give us 450. 1 plus 350 equals 450. Okay, now for the last question. This one isn't worded, so let's just get straight into it. We need to rearrange this equation. We need to rearrange one of the equations so that the x's and y's are lined up. So we'll go ahead and rearrange the top equation, so it's easier for us to cancel out. So we're just moving the x's and y's around. So 3x plus 2y equals 11. X minus y equals 4. Okay, so if we multiply this bottom equation by 2, we can go ahead and get the same coefficients for y. So let's do that, only doing it to the bottom equation. The top equation remains unchanged. Gives us 2x minus 2y equals 8. Now, plus and a minus, we're going to plus to cancel out. So we're going to plus everywhere else too. 5x gives us 19. X equals 19 over 5, which is 3.8. Now let's find the corresponding value for y. Let's sub it into the first equation. .8 times 3 gives us 11.4. Two y gives us minus 0.4, so y is minus 0.2. Okay, now let's sub both of these values into the second equation, and that should give us 4 as our answer. 3.8 minus minus, which is a plus 0.2, and yeah, that equals 4. Okay, so I hope you found this lesson useful in understanding simultaneous equations, what they actually are, what we're trying to solve for, and the steps included to actually work these questions out. Now, this was part 1, it was linear. The next part is going to be looking at quadratic simultaneous equations, which is still similar to what we have done today, but just with a few more steps. Okay, so well done if you got these questions right, and I will see you on the next one.